Hello, in this video we will see the an example to understand how to calculate the gain. In There are many methods like calculating in term of GM times of R equivalent, but here one more method is that current multiplied by the R, that is also there. So let's see how we can use that. So before that, there is one example, one concept that if you see here closely, let's say this is open circuit, okay, and for this, what is the V out? Diode connected, but this is open circuit, the output will be VDD. Why is this so? Because we know that here VGS is, let's say VS is 0, let's say that this potential is 0, let's say this potential is 0, then this VGS is greater than VT, simply on, but there is no path to current flow. It means the characteristics will be defined by here and VDS is here 0. So output is same as VD. Okay, and once it is VDD, the VGS value is 0, then transistor automatically off. So this potential will not go away, it will remain as it is. So whenever you see something like this open circuit diode connected, it means this potential is VDD. What if it is VDD? Okay, so this is the basic concept that we can use. Now let's go to the our example. Okay, so here simply if you see here at t is equal to 0 positive, I have switch that have given V in, and this is my circuit that simply current mirror here. Okay, and this is the load. What is the V out? Simply at t is equal to 0 negative, when switch is off, this is ground, VGS is 0, there is no current. What does it mean? This VGS is 0, so this VGS is 0, this VGS is 0, there is no current in this branch. So what does it mean? That V out will be short circuit to ground, and this is 0 volt. Okay, now if at t is equal to 0 positive, since potential at this is defined by the caps on this load, on this node, so let's say at t is equal to 0 positive, it is VDD and this is Vn, and so thus this is in the saturation, so there will be current flow here, and after, since there is a current flow, this will form some VGS, so slowly this potential will go down. But at t is equal to 0 positive, there is a start of current flow, and you can say that there will be some drop in the VDD will be, V out will be increased to some value, slowly it will be greater than 0 and it will start working. Okay, now let's go to the circuit now. So this is my point here to explain that if this is this is my current mirror, so what I will do, just take the current here, it will be defined by GM times of this and VGS. Let's say R0 is infinity, in that case it is GM1 V in, and current in this branch M3 is whatever the current here multiplied by the ratio of the size, aspect ratio. So whatever the current in this branch, GM1 V in multiplied by WL by 3 by WL by 2, so this is the current, and the V out will be defined by the current multiplied by resistance. So the V out by V in is simply calculated through the current through this branch multiplied by resistance. So by this you will get this V out by V in. So the important point here to analyze is that we have used just the simple current equation and multiplied it through by the resistance. So simply this branch simply this branch current is gm1 v in, and this branch current is defined by the whatever the current in this branch I1, it is I1 multiplied by the aspect ratio of M3 divided by aspect ratio of M2, and multiplied by R2 will give the R out, and so thus we will get easily the gain. So this is very beautiful that we can use the current equation directly for the gain calculation. Now let's go to traditional way of analyzing. Traditional way of analyzing is says what does it say? It says simply that if this is my device, this is V out. So what I will do, from this to this, what is the gain? The gain is defined by gm of this and R equivalent resistance, and that is equal to this gm1 and gm1 by gm of this multiplied by 1 by gm of 2, let's say, multiplied by R naught of 1. So it is equivalent to 1 by gm2. So this is one gain. Now this gain from here to here, okay, so this gain is, what does it is, gm3. So gm3 multiplied by R equivalent seen here. R equivalent seen here is whatever the resistance R03 and RL. Okay, so from A, B, A, this is B, this is C. So A to B gain is defined by this, B to C is defined by this. So gm3, let's say RL, okay, and total gain, you need to multiply this. Basically C by A is C by B and B by A. So B by A is this, and from here you get to know that I just mentioned above that gm3 is gm2 times of aspect ratio of the two aspect ratio. Okay, so gm3 is mentioned in term of gm2, okay, and multiplied by R2, and here gm1 divided by gm2. So from this you will get the gain equation. Okay, but this is the way, traditional way of analyzing, and in the quickest way, that is I liked it, very useful, that whatever the current, just take it and multiply it through the resistance, will give you the voltage at that potential. And you just need to understand that current is defined by gm vgs. Only condition is I have taken R naught to be infinity. Okay, so in that case you can analyze in this way. So this is what I wanted to share in this video. Thank you. Hope you